Have you ever gazed up at the vast night sky and found yourself asking, why exactly is space black? If the universe truly contains an essentially infinite number of stars, then logic dictates that any line of sight you choose would eventually terminate on the surface of a star. You can actually observe this phenomenon within Space Engine. If you literally click anywhere on your screen and travel to that specific object, it will turn out to be a star. Therefore, instead of appearing the way it does now, the sky ought to look like this, yet it simply doesn't. This phenomenon is known as Olbers Paradox. In this video, I am going to demonstrate how this paradox is finally resolved and attempt to determine exactly how black the night sky actually is. In the process of doing so, we will encounter another intriguing question. Is it even possible for us to perceive 100% blackness, even if there were no stars at all in the entire universe? To properly grasp this paradox, we first need to be very clear about what we expect to see if there are a vast number of stars throughout the universe. You might be thinking to yourself, well, the majority of stars are located very far away, so they are just extremely dim. That is the reason why we don't see them. And that statement is true. The total amount of light we receive from each individual star decreases with distance, but at the same time the star also appears smaller by the exact same factor. These two specific effects cancel each other out, so the apparent brightness of every tiny patch of a star's surface remains the same. For instance, let's examine this light right here. Notice that the objects possess the same brightness in one specific spot. It is just that the one I move further away appears smaller. For example, if the total amount of light hitting the camera is represented by F, and the area that the light source occupies is omega, then the surface brightness is F divided by omega. Now let's move the phone back so it is only a fourth of the original size. Well, that means the amount of light hitting the camera is now a fourth of the original light, and the area it takes up on the screen is also a fourth of the original size. Consequently, the fourths cancel out, and we end up with the same original surface brightness. So when you see a star in the sky, that brightness is actually about the same as the brightness of the sun, but it is just occupying a tiny little pinpoint of space in your field of view. And so it doesn't seem as bright even though that single point is as bright as the sun or even brighter. Therefore, every single point in the sky would have roughly the surface brightness of a star. In other words, the night sky should literally look like the surface of the sun. This paradox had puzzled astronomers for many centuries. Since the 1500s, many people held the belief that the universe was infinitely old and infinitely large. Great thinkers like Johannes Kepler and Edmund Halley wrestled with this very question. And in 1823, Heinrich Olbers published a well-known discussion regarding it. His name eventually became attached to the problem, and today it is known as Olbers Paradox. So what is the actual solution to this? Well, the answer began to reveal itself when astronomers started questioning one of the paradox's biggest underlying assumptions. What if the universe wasn't actually eternal? In the early 1900s, we discovered that the universe wasn't infinitely old after all, so perhaps the sky is dark simply because the light from the most distant stars hasn't had enough time to reach us yet. But unfortunately, that doesn't solve the paradox either. The reason is because the early universe didn't look like random stars just popping into existence. In fact, it was even weirder than that. Right after the Big Bang, the universe wasn't mostly empty like it is today. Instead, all of space was filled with an incredibly hot, dense plasma. Everywhere you looked was glowing plasma. So if we look far enough back in time before there were any stars at all, we shouldn't see darkness. We should see that hot, glowing plasma in every single direction. So, we're right back to where we started. The night sky should still look like the surface of the sun, but then once again, why is the sky so black then? Well, the final piece of the puzzle came later when we discovered that not only is the universe not infinitely old, but it's also expanding. And an expanding universe does something really strange. It basically steals energy from everything. More accurately, as light travels through the expanding universe, its wavelength gets stretched. Longer wavelengths carry less energy, so every photon gradually loses energy as the universe expands. Eventually, the wavelength becomes so long that the light leaves the visible spectrum altogether. So all of the visible light that we should be seeing from the hot plasma that once filled the entire universe has been stretched into the microwave range. And sure enough, guess what we see when we look in every direction in the sky? We see microwaves. It's almost exactly what early astronomers predicted, a glowing sky in every direction. Except instead of visible light, it's been stretched into the microwave part of the spectrum. We now call this the cosmic microwave background. No matter where you look, you see it. The sky really does glow in every direction. It just glows in a color our eyes can't see. But just how black is this blackness? In the city, the night sky can be around 1 lux, which looks something like this. But if you're out in the middle of nowhere, far from any light pollution, the brightness between the stars can drop to only about zero point 0.3 millilux. So what would that look like? Well, it turns out that it's so little light that after your eyes fully adapt, your own visual system becomes one of the limiting factors. And something really interesting happens when we block out all the light possible. So let me show you what this blackness looks like. Turn off the lights completely and cover your eyes so that no light can reach them. So the color you're seeing right now isn't actually pure black. It's called eigengrau, or intrinsic gray. Compared to true black, it looks something like this. So eigengrau is the darkest color that we can physically perceive. We can't actually see true black. The reason is that the rods in our eyes don't only respond to light. Every so often, random thermal motion inside the retina activates them even when no photons are present. So your brain interprets these random signals as a faint gray instead of perfectly black. So it's as though we're constantly seeing a very, very dim light everywhere in our vision. In the end, the early astronomers were right to question why the night sky was black. It turns out they were right in more ways than one. The universe isn't truly dark because it's still filled with the glow of cosmic microwave background. And even if there were no visible light at all, our own eyes would still refuse to let us see perfect blackness. If this journey through the cosmic darkness has changed the way you look at the night sky, please subscribe and like the video. We are uncovering the mysteries of the universe that time has tried to hide. Let's illuminate the future together. The next cosmic treasure will be revealed soon.